Well, hi everyone, it's Mr. Freiberg speaking, and welcome to week 2 of Year 8 Maths in Term 2. And we start off our week with lesson 4, so this is the first lesson for the week, but the 4th lesson for the term. And your title, which I will get you to write down today, is Powers of Powers. Okay, you can see the title there on the screen. So, with Powers of Powers, we'll be looking at that today. We'll also be extending upon it tomorrow. So it's important that you complete this PowerPoint presentation and the questions that are in it before our live lesson on Tuesday, so that you get a little bit of a better understanding of what's going on. Obviously, the intention is that you are completing this lesson on Monday the 27th of April. So make sure that you write the Powers of Powers as your title and also the date in your maths book. Again, the notes are accessible for this on the eLearn Classroom, as are these slides, so you are more than welcome to follow through this video with the slides or with the handout and then fill in the blanks as we go along. So if you're writing in your book, the learning intent for today, which I'll get you to write down, is to develop the Powers of Powers index laws on numbers with positive integer indices. So very similar to what we did in our live lesson last week. If you need a bit of extra time, please pause the video. And the success criteria will be to expand Powers of Powers into its factors, so we get a bit more practice at writing some terms out in factor form or expanded form, and then hopefully we'll come up with the index law that will then enable us to simplify Powers of Powers rather quickly and conveniently. So as a little bit of a review, so far we've seen things like a to the power of 3, and we have said that the number on the bottom, which is the base, bottom, that's the number that gets multiplied together a number of times, and the little number that's up the top, the 3, that's called the index, and the other word that we have used to describe it in the past has been the power. So you can call that the index or the power. Now, if you're working through this with your book, you might like to write down the answers for the following questions. Similar to what we did in the live lesson last week, 8 to the power of 2 has a base and an index, and you can write down that the base is 8 and the index is 2. Now, if you're watching this on video, you might like to pause the video and you might like to try those other 3 questions, and we'll come back very shortly and we'll check the answers. Okay, so with these other 3 down the bottom here, the base of k to the power of 16 is k and the index is 16. With the 8 to the power of w, the base is 8 and the index is w. And then with the last one, the base is d and the index is 9. So d to the power of 9, and we'd be multiplying d together 9 times. We should be happy with that, and if we're not, folks, you need to send Mr. Freiberg, myself, an email as soon as possible so that you can get this sorted. Now, as a review, I'd like you to then now try and solve those 6 questions that you see on the board. These are pretty much based on last week's lessons, particularly the multiplication and division index laws, and also the zero index law, which we looked at on lesson 3 last week, which I believe you did on Thursday. I'm going to give you 10 minutes, or I would normally give you 10 minutes, and so I'd like you to spend that time right now trying to simplify the following questions, either in your book or on the handout or class notes, which you have hopefully downloaded from the online classroom. Please pause the video now so that you can attempt these questions. Okay, so there's the answers for the first 5, and if I quickly run through these answers with you on the screen. The first one, 4 to the power of 3 multiplied by 4 to the power of 9. The bases are the same and we're multiplying, so we simply add the powers together. So 3 plus 9, 4 to the power of 12. Give yourself a tick if you tried that one and you got it right. Now the next one says 2d to the power of 7 times d to the power of 5. Again, the bases are the same. We're multiplying it, so we're going to add our powers together. But what about the 2 out the front? Well, even though it's not written in there, there is a multiplication sign in between that 2 and the d, just in there. Okay, so that 2 actually now gets placed out the front and it gets multiplied by d to the power of 7 plus 5. So the final answer becomes 2d to the power of 12. Again, give yourself a tick if you got that one right. What about if we have two numbers, a number out the front of that one and a number out the front of that one? Well, let's deal with those shortly. The thing I'm interested in though is that the bases are the same and we're multiplying. So again, I'm going to add my powers, b to the power of 6 plus 2, b to the power of 8. So there's that first bit. Now what about the numbers? Well, there's your multiplication sign, and that's telling you you're going to go 3 multiplied by 4, and we know 3 times 4 is 12. So there's your final answer, 12b to the power of 8. So they're the ones that use the multiplication index law, where we add the powers provided the bases are the same. What about part D? Part D now has a divide by sign in it. Well, again, we look at the bases, they're the same, but now we're dividing. So the division index law last week said that we subtract the powers. So I'm going to go 18 minus 7, and that gives me 11. So m to the power of 11 for part D. Now, even though there's a line, a fraction in part E, you need to remember that the line in a fraction, as we looked at quickly last week, means divide. So part E is actually saying c to the power of 13 divided by c to the power of 9. The bases are the same. We're dividing, we subtract the powers. 13 minus 9 is 4, and so c to the power of 4 for that one. The last question, which I didn't write down, is part F. 435 to the power of 0 equals 1. Because last week we learnt that anything raised to the power of 0 equals 1. So that's the review of week 1's work. And as I said, if there's anything there that you are not sure about, please email Mr. Freiberg. Please email me as soon as you possibly can, and we might be able to get it sorted. I have also added, as I mentioned last week, a small video in the discussion board that also goes through the multiplication and division laws. If you might like to quickly view that as well, it might help you understand some of those a little bit more. All right, let's have a look at this powers of powers index law. So I'm going to show you this like I did in the live lesson last week. I'm actually going to write these out in expanded form. So, for instance, 2 to the power of 3 to the power of 4 looks a little bit like this. I've got 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. So, by definition, 2 to the power of 3 to the power of 4 means that I've got 2 to the power of 3 multiplied together 4 times, like you can see on the screen. Now, what we learnt last week was that when the bases are the same, and you can see they all are, and we're multiplying, we simply add the powers together. So when I simplify this, I go 2 to the power of 3 plus 3 plus 3 plus 3. And you can see that 3 plus 3 plus 3 plus 3 equals 12. So the final answer for that first one is 2 to the power of 12. What I also suggested to you in the live lesson last week is, can you see something that links those two powers, the 3 and the 4, with the final answer being 12? Let's take a look at the next one. The next one says 4 squared to the power of 6, or 4 to the power of 2 to the power of 6. So that means I've got 4 to the power of 2 times 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 4 to the power of 2. Again, all the bases are the same. There they all are. And I'm multiplying, so I'm simply going to add the powers together. So I'm going to go 2 plus 2 plus 2 plus 2 plus 2 again, and plus 2 one more time. 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. So 4 to the power of 2 raised to the power of 6 equals 4 to the power of 12. Can you see a pattern? Can you see a link between the two powers over here, 2 and 6, and the final one, 12? I hope you can, because this is the third index law, or sorry, the fourth index law. And this is the one where we raise a power to a power. And what you might notice is that if you multiplied 2 times 6, you end up with that power of 12. Take a look up the top. 3 times 4 gave you the power of 12. Using that shortcut then down here, if I multiply 4 and 5 together, 4 times 5 is 20, the answer for 7 to the power of 4 to the power of 5 should be 7 to the power of 20. Boys and girls, that is the fourth index law, and that's called the powers of powers index law. So that's index law number 4. And it says that if you have any base raised to a power, which is then raised to another power on the outside, you multiply the powers together. There it is right there. So if you've got your book open, could you please write down in your book the heading and also the index law, and maybe write a number 4 next to it, because that was the fourth index law. You might also, as I suggested to you in the lesson last week, the live lesson, is that you add that to the back of your book with your other 3 index laws so that you've got them all in one nice neat place. You might like to pause the video here for a couple of minutes so that you make sure that you get this down properly. Okay, now you've written all that down. Let's take a look at some examples, and these examples are reasonably straightforward, I would hope. 10 to the power of 5 to the power of 6. So I'm raising a power to another power. So all I simply do is I multiply those two powers. So I've got 10 to the power of 5 multiplied by 6, and we know that 5 multiplied by 6 is 30, and so the answer is 10 to the power of 30. It's really, really useful to have this shortcut, because I know I don't want to write out 10 30 times. So I'm just going to write it out as 10 to the power of 30. The second one here, which is 4 to the power of 5 to the power of 3. Again, I'm raising a power to another power. So I simply multiply the powers together. 5 times 3, gives you 4 to the power of 15. You might like to pause the video here and try the third one yourself. A to the power of 7 to the power of 5. You're raising a power to a power, so you're going to multiply. So after you multiply the powers, 7 times 5 equals 35. Just as a little bit of a precursor for our live lesson tomorrow, I've also thrown in here part D. Now I've put part D in here because this is what these questions mostly look like when it comes to powers of powers. And part D says 3c to the power of 9 raised to the power of 6. Now the way that I'm going to show you this one is I'm just going to ignore the 3 for the time being. Makes this question a little bit easier because you're raising a power to a power. So you've got c to the power of 9 times 6. So we raise a power to a power, we multiply. 9 times 6 is 54. So what do I do though about the 3 out the front? Well, I'm going to show you tomorrow that there is a little complication with this one. And that is that we also need to raise the 3 to the power of 6. Okay? So that 3 also gets raised to the power of 6. So out the front we actually have 3 to the power of 6. Now, you can leave it as 3 to the power of 6 times c to the power of 54, but that kind of looks a bit silly. So in actual fact, what we should do is we should get our calculators out and we should actually type in 3 to the power of 6. So if you have your calculator handy, type in 3 to the power of 6, you'll have to find your power button. It's usually the one with the X with the little coloured in square next to it if you've got your Casio calculator. Otherwise it might be a button that has like a Y with a little raised to the power of X on it. Or you can just type in 3 times 3 times 3 times 3 times 3 times 3, Either way, you should end up with 729. So 3 to the power of 6 is 729, and so the final answer for that last one should be 729 c to the power of 54. So those questions there all rely on this fourth index law, and the fourth index law says that if you are raising a power to a power, you multiply the powers. If you are having any troubles with that, please make sure that you email Mr. Freiberg, myself, as soon as you possibly can. So we've expanded powers of powers into its factors, and we did that to hopefully then come up with our index law, which enabled us to simplify powers of powers. Let's do a little bit of checking for understanding. So you can obviously pause the video and try these ones if you want to, or maybe just while I'm babbling on here for 10 seconds, you might actually be identifying what the answer is. The answer, we're going to multiply the 3 by 5 because they're the powers, and we're going to get 4 to the power of 15. The next one, s to the power of 4 raised to the power of 7. Again, we're raising a power to a power. So again, we're going to multiply 4 times 7, 28. Can we expand powers out? Yes, I think we can. Can we simplify them using those power law? I think we can. Folks, the exercises that I want you to do are pretty simple. There's only one set. It's out of unit 1.6, which is called Powers of Powers, which is in your textbook. And if you're watching this at school, you can use your textbook, page 47 to 49. And all I want you to do is just question 1. Once you've finished that, then like I say there, take a scan or a photo of your completed work and save it in the assignment Dropbox on the eLearn Classroom or email it to me. Thank you very much for all those lovely people last week who have been emailing me their work. It's been much appreciated. For those people who I haven't heard from yet, I hope I hear from you this week. Otherwise, we might have to start letting some people know you may be missing in action. If you don't have access to your textbook, there are the questions there. There's only 8 of them, and you'll notice that they are all pretty straightforward. I'm going to touch on the slightly harder stuff tomorrow in our live lesson, but as I said, it's important that you've got these done before you come to the live lesson tomorrow. So that's it for this first lesson in week 2. Just showing you quickly the powers of a power. Index law, and as I said, tomorrow in our live lesson we're going to build on that a little bit more and look at those harder questions like that last one in the example where you also have to raise the number out the front to a power. That's called the multiplication powers of powers index law. There's also a division powers of powers index law, and where we're heading by the end of this week is that you'll be using those plus some of the other index laws that we've looked at all in one go. So one question, perhaps using 2 or 3 index laws. It will start to get a little bit challenging for some people. Some people might be up for the challenge and looking forward to it, and I hope you are, because index laws, as you've seen, are a really, really nice, neat way to actually simplify some very large expressions. Anyway, that's enough for me for today. I hope you've enjoyed this lesson, and I will see you at the live lesson on Tuesday. Bye-bye.